idea of taking a sample and studying its properties in order to study some truth about the larger population is really great, and we actually do it all the time, but it's often misused. For example, let's say that just this past week you experienced not one, not two, but three old Asian men almost crashing into your car by driving recklessly. Then it's really hard not to think, wow, old Asian men are really terrible drivers. The problem with this kind of thinking is what we call in statistics small sample size. See, if I toss a coin 3 times, then it is possible, although unlikely, that all 3 times it lands on heads. In fact, the probability of that is more than 10%. If that happened, you wouldn't think that the probability of heads is 100%, right? So obviously, a sample size of 3 is too small to make any conclusions. So what is a large enough sample size? It turns out that you actually need a lot, and it depends on the variables. Sometimes you might need 100, sometimes 200, sometimes even you need 1,000 observations in order for your sample to truly represent the characteristics of your population.
So for example, I used a random integer generator to generate tosses of a coin. And what we're going to do here is we're going to graph the percent of heads that we have so far. So my first toss I got heads, so that means we are at 100% heads. So we see that dot there at 1, that means 100%. Then the second toss was heads, we're still at 100%. Third toss was tails, so now that is 2 for 3 heads, or 67% approximately. Then the next one was tails, so now we're at 50%, or 0.5. And then finally, actually, fifth toss was tails also, so that leaves us at 40% heads. And now, let's say I keep doing this for more than 200 tosses of a coin, then I got this graph. So there are two things that you have to observe in this graph. One of them is that small sample size problem showing up at the beginning of the graph. So you see for the first, even the first 70 tosses, you see the graph hasn't really settled at 50% as it's supposed to. It's still at about 55%. Let's say that someone tossed this coin 40 times, which is about 60%. Then this person could easily think that this coin is flawed, right? They might think, wait a minute, this coin is unfair. It's landing 60% heads. But you see, the problem there would be sample size problem. The other thing we observe in this graph is that eventually the graph does settle at 50%. And that is what we call the law of large numbers, which says that as the number of experiments increases, meaning in this case tosses of a coin, the actual ratio of outcomes will converge on the theoretical or expected ratio of outcomes, which in this case would be 50%. So the law of large numbers is really the reason why we can do statistics. It's the reason why we can take a sample, as long as it's large enough, to study some property about the population. So maybe next time, if you meet 100 old Asian men who are driving recklessly, then you might be onto something.